Okay, so now we're going to have a brief discussion on recognizing the subsets of complex numbers, because this background is sort of important to understand what is going on when we add and subtract complex numbers, multiply complex numbers, and divide complex numbers. Okay, so in this video we're only going to cover objective 2, 3, and 4, because we're just trying to keep these videos somewhat manageable and short. The last video, part 3, will cover dividing complex numbers. So let's just first start off defining the complex number system. Is an extended number system that includes the real number system as a subset. And remember, we did talk about these definitions here, where I is equal to the square root of -1, and logically I squared is equal to -1. So remember, we said that the complex number system includes real numbers as well as non-real complex numbers. And what we're talking about here, this is the standard form of a complex number. But just at this point, complex numbers do involve real numbers. And as you can see here, in this case, the B part of the standard form is 0. So your real numbers can be represented in a complex way. Notice here we have -8. It's a real number, and its standard form is -8 plus 0i. So the 0i part of it cancels out, so we just get -8, right? But all real numbers can be represented in the complex number system. So again, we have 0, real number, 0 plus 0i. So that 0i part cancels out. So the moral of the story is real numbers are included in the complex number system. And so far we've talked about numbers like this, 3i. It's an imaginary number. But notice here in the standard form, which we're talking about a standard form here, a plus bi, a and b are real numbers. A is the real part, b is called the imaginary part. So notice here, going back to -8, here we have a real part and we have an imaginary part. So in this case, where we have 3i, the numbers we've kind of worked with so far, the real part is 0, but we have 0 plus 3i. Here we have another imaginary number, and notice that it is represented in this way. The real part is 2, and the imaginary part is -1. And then here, a little more complex representation of an imaginary number. So going back to the subsets of complex numbers, we have a plus bi as the standard form. And if b is 0, then it's a real number. And we said real numbers are a subset of complex numbers. In this case, where we're talking about this 3i, that is a pure imaginary number. But then we have a situation 7 plus 2i. This is a non-real complex number. And again, just to emphasize, a complex number written in this form, a plus bi, is in standard form. So going back to what we were talking about, complex numbers include non-real as well as real numbers. Real numbers just have the situation where b is equal to 0. And then, of course, real numbers include irrational numbers, rational numbers, integers, and non-integers. So at this point, let's go ahead and start about adding and subtracting complex numbers. So here in part A, we are going to add those two complex numbers. So what we do is add the real parts and add the imaginary parts. So another way of saying that is we combine the real parts and we combine the imaginary parts. So the imaginary parts and the real parts can't be mixed, and to use probably a non-mathematical term. But anyway, here's the idea. So notice that they've separated in the blue the -1 and the 9. So we're going to combine the real parts. And then notice we took -8 and -3, which were the imaginary parts, and then we're combining them. So basically what we're doing here is combining like terms, which is something that we've done before. And so we just consider that I as a variable, perhaps. Remember that I is just a number. So what in a sense what we're doing is combining like terms. So again, we're adding the real parts here. Then we're adding the imaginary parts. So let's go ahead and look at the next step here. So here we have a result where we added two complex numbers, and our answer is 8 minus 11i. And that's the way that the answer is going to be represented. Now in B, we have a little more complex example here, and ironically complex numbers, but anyway, we're going to still do the same concept. So think of this as combining like terms. So here we have a situation where we are adding the real parts and adding the imaginary parts. So there we would come up with -9 minus 6i. Again, we just combine the real parts and combine the imaginary parts. Now subtracting is going to be done in the same way. The only thing is, what's going to happen is you're going to distribute that negative throughout the complex number on the right. So here's what we have. What they did was distribute that negative through there, and we ended up with this result right here. Again, combining the real parts with the imaginary parts. And here another example that we're going through here, distributing the negative throughout, combining the real parts and the imaginary parts. And then notice how these answers are represented, how these complex number answers are represented. And then C is a similar situation, combining the real parts and the imaginary parts, distributing that negative throughout the latter term of the difference. And notice here we come up with a pure imaginary number because the a part of the standard form is 0, so we get a pure imaginary number there. So here's the homework problem that addresses adding and subtracting complex numbers. So it simply says find the sum. So the first thing I've got to do here, let's deal with what is in the brackets, right? And the first thing I've got to do is distribute that negative throughout this part of the complex number. So let's go ahead and rewrite this here in the bracket. We'll have -4 plus 8i, distributing a negative minus 3 plus 9i. And then we have the piece that is outside of the bracket still. So now I'm going to combine this part right here. Remember, add the real parts and add the imaginary parts. So I do -4 minus 3, I get -7. Then I do 8i plus 9i, and I get 17i, bringing down this other piece right here. So now I'm going to continue combining the imaginary parts and the real parts. So negative 7 plus 9 gives me 2. Then I combine the imaginary parts. 17 minus 9i gives me 8i. So there we go. We just found the sum by using our procedures for adding and subtracting complex numbers. So now let's go ahead and look at multiplying complex numbers. Okay, so multiplying complex numbers is going to require that we have some knowledge about the imaginary unit I. And basically we're going to use this rule here where I squared is equal to negative 1. So this rule right here is going to be very important to what we do when we're multiplying complex numbers. Okay, so here's the first multiplication situation. So we're going to treat that 6i just like we would any other number, and we're going to distribute it across that binomial, you can think, but it's, it is a binomial, but it's how it's the standard form of a complex number. So we treat it like distributing across a binomial. So as you can see, we're distributing that 6i across that complex number. So we continue with multiplication. So 6i times 4 is 24i, and 6i times 3i is 18i squared. Here's where that rule that we were talking about, I squared equals negative 1, is going to come in when we multiply complex numbers. So notice here we replace the I squared with negative 1. So we continue with multiplication, and we come up with the answer right here, negative 18 plus 24i. So this problem involves imaginary numbers, right? Complex numbers, where we're represented by the lowercase I. So if you remember, a big key to this situation was that the square root of negative 1 is I. And that being said, I squared equals negative 1. So based upon those two rules, we can form this product here. So let's just zoom in first of all. What's happening? We're just going to distribute here. We're going to distribute here in this way, and we're going to multiply that out. So that's all we're doing here. Now let's just zoom back out here and look at what we're doing. So we have 7i times 6i minus 5. So we're simply distributing that 7i throughout there. So 7 times 6 is 42, and then I times I is I squared. Then 7 times negative 5 is negative 35. Remember, I squared equals negative 1. So we replace that I squared with negative 1, 35i, I left that out. But anyway, so there we go. And so that ends up being negative 42 minus 35i. And notice we are in the correct form here. So that's our answer right there. Okay, so here we have another case of multiplying complex numbers. Notice that we have two complex numbers that are in sort of a binomial form, in that standard form there, where rather than multiplying a pure imaginary number in a previous example times a complex imaginary number, now we're multiplying two complex numbers in that standard form, a plus bi. So we're going to use basically the rules that we have done by multiplying binomials, and that is to use FOIL, which we have here. Remember, FOIL is first, outer, inner, last. So as you can see, we multiply 3 times 3, and then 3 times 4i, and then 2i times 3, and then 2i times 4i. So using FOIL, this is what we come up with. So there's a couple important things to note. Notice in the middle we have 12i plus 6i. So we're going to have to combine those. And also notice that we have 8i squared. So we're going to have to do some work with that I squared. Notice and remember, I squared is equal to -1. So we go to our next step. Notice that we've combined 12i and 6i, combining like terms, and notice that we've converted that I squared into a -1. So we continue on down. Notice that that now became -8. So we're going to have to combine those real parts to simplify this further. And here we have 9 minus 8 is 1, and we end up with the complex number 1 plus 18i. Okay, so we're now going to deal with this multiplication of two complex numbers. So remember, we're going to use FOIL here. So if you remember FOIL, it is first, right, outer, inner, and last. So here we go with the process. 6 times 7 is 42. 6 times 7 is 42. 6 times -4i is -24i. 2i times 7i is 14i. And 2i times -4i is -8i squared. So there are two critical steps to this. First, remember, we've got to combine these imaginary parts right here. And the other thing we have to deal with is this I squared. And remember, I squared is equal to -1. So here we go. We go ahead and bring down the 42, combine -24i and 14i, we get -10i. And then one thing that I like to do is I always include this step right here where I am dealing with this I squared. You know, it's a little bit extra writing, but sometimes it helps to make sure that we keep these things straight. So we're going to continue on here, bringing down the 42. We still got the -10i. Then we deal with this -8 times -1 part. That turns that into +8. So at this point, the last thing I've got to do is combine these real parts to finalize this problem. So 42 plus 8 is 50. And then we bring down the 10i. So here we have our solution to this multiplication problem.